And I guess I better open one in case somebody has a question. Yeah, as I said earlier, I just read this long article about Excel, and I was amazed at how much, okay, so in my fields, people basically um, look down their noses at Microsoft Excel. Oh, but it really became one of these dirty little secrets where people like I just started using it without telling anybody. And it turns out lots of people were doing that. They weren't owning up. They weren't fessing up. And but um, a spreadsheet is a really great way to take quick looks at data and do quick what if analyses. It's associated with the financial world, but a lot of people do. And what Microsoft Excel has built into it, this thing called macros, where in a simple sense it just memorizes keystrokes, but a spreadsheet is also a computer program. And I was just stunned by how much software has been developed using Microsoft Excel. I never would have suspected. And it's just everywhere. And in terms of you guys and me as what I consider my responsibilities as a professor to prepare you for the outside world, um, there's just too many good reasons that we should be using Excel. And in the beginning, I was 4 years ago, but I didn't. Google Sheets were guaranteed to be free all the time. And yeah, after you graduate, you may have problems with accessing Excel. But if that happens, there's a thing called Open Office or LibreOffice. So, but we'll get into that another time. But when you apply for a job, you'll see commonly on on job postings, they'll either say proficiency in the Microsoft Office required or proficiency in the Microsoft Office preferred. So that means that the person that goes into the job interview that knows how to use Office, and especially Word and Excel, is going to have an advantage over the person who doesn't. And so it's really it's a useful skill for you guys to have, and it's in your bag of tricks when you apply for jobs. And so we're going to use, that's why I really like to use Excel. Okay, so we need to prepare a spreadsheet. And let's first of all, let me unclutter this a little bit. And I want to, in fact, I want to just clear all the data, but I don't want to clear out the other stuff I set up. And so I'm going to delete the numbers. I'm going to delete my formulas. Come on, baby. Okay, there we go. Okay, so you see I've got Mastercard 1, Mastercard 2, and let's see, this is going to be in kilograms and kilograms. And I have time, and you can see these various headings right here. And then so at first, when I typed them in, it kind of looked, oops. You're going to notice that it's going to be looking a little funky. And especially since it's only, so that looks pretty lame. So what we'll do is we just Google Sheet can do the same thing. Select that row, and you can make it bigger. And then, and let's see. So in Microsoft Excel, you just have these buttons up here. So we center it in left, right. We center it up and down, and then we want to wrap the text. And then in the Google Sheet, wherever the heck it went, oops. So let's copy. And that was starting in D1, huh? Okay. And I paste. And again, see, it looks kind of funky, although it did remember to align to the left. So it put the middle. But generally speaking, when you type stuff in, it defaults to this kind of look and feel. So now we select that row. See how the arrow changed, and make it about 2 rows. And now you go to, we want to center it left and right, center it up and down, and we want to wrap text. And that just means it creates a new line for us automatically. Okay, why is the phone pestering me now? Okay. No pre-lab, not published. Great. Man, I spent a lot of my time on Sunday I noticed last week I wasn't as ready for the week as I should have been. All right, so we got these headings, and we've got masses here. So what we're doing is we're going to set this up, and then we can just duplicate the sheet, and whenever we take some data with our simulation, we can just copy paste it into there, and we can get numbers. Okay, so let's take a look. Now, hopefully you had a little chance to play with this guy. And how do I just clear it? Is there a way to just reset everything? That says okay, you can make screenshots. How does one? No, that stinks. Because if I click to start and stop, data erased on start. Problem is, as soon as I do that, it starts taking more data, and I want it to just want to Z it out for the time being. Oh well. But anyways, let's try something here. So the way you hook it onto the plunger is you just slide it over and it does it for you. And you can set how much you want to have it release, how much force, and basically that means how fast it's going to go. You can't actually set it to be a precise number like the other simulation. Okay, so we got this thing going. So we can turn on the detector and we release it. Oops, it bounced off the back wall. I didn't want that to happen. But, oops, and let's stop it. So this thing produced a graph for us. But what we can do is we can copy it all to the clipboard by just clicking that button. Now I don't know why it does this business here. Maybe there's an amount of time, this plunger has some time. But if we remember our things we learned for linear acceleration, we notice, oh my goodness, look at that. Constant velocities, right? Constant slopes. And we have some sort of instead of a smooth transition here from negative to positive, it is abrupt, basically telling us it's an infinite acceleration, isn't it? Is it? Infinite force? Because remember I was talking about the time in contact earlier? But anyways, so we've gotten that. We said copy to clipboard. And notice time and position. So if I click here and I say paste, there's all my numbers. Neat.
So you want us to do that?
Yes, sir. Yes, please. So you should have either an Excel spreadsheet open or a Google Sheet, as the case may be. Oh, excuse me. What time is it? Oh, I'm running out of time. Okay. Okay, so remember, now you should write this down. We look at our preliminary graph. First of all, we should realize, and it is spelled out in the manual here. So we're just to be sure, where'd it go? Oh, here it is. This is our manual. There is a certain, now this one here, let's see, there's no collision here, I guess. Oh, I see. Okay, there's different parts. This one is a little more general, but there's different areas represent different things on the graph. So when they're sitting still in their starting positions, then there's no change. So there's no change in the position here, right? So V equals 0, and that is the blue card. And then here, the V red card also equals 0 because it's a 0 slope, right? Now we also see, okay, this is when we clicked on release both. And the blue card, this is a negative slope. So the blue card went left and the red card went right. And they're constant slopes. Right? Because they're straight lines. And this is when they hit each other. And now this is a positive slope because the blue cart now is going right, right? Because it hit and it turned around. And the red cart is going in the negative direction now. It's going left. Again, at a constant speed, right? This is the kind of thing you want to make sure you're writing down these general concepts. You're writing this down in your logbook because you need this later for your report and your analysis. And then, of course, here is where it hit the wall. And you also notice that they're slowing down, which is interesting. Oh, right, because it hit the springs, and the springs, it's not, this is a partially inelastic collision. So just, this is after hitting the spring. So this is an inelastic because these spring, in principle, it's not, but the way they make it is the springs, they convert. So some of the Ke becomes thermal. The spring gets a little warmer. And so this is inelastic because the slopes are not the same. Notice now these slopes are basically the same before and after. And in fact, not only that, uh, um, this is an external force. Even though, of course, it started them, we don't care about what happened at this up until here, until it pushes. We only care about when it leaves, when the cart leaves the plunger. We don't care about this area here. So in the ideal world, let's see if I can get my shit together here. Mouse. So if I get this going here, and this going here, turn on the sensor, and then I stop it before it hits the back wall. Well, the only thing now, this is a little dissatisfying here, see, because, but the slope is what we care about, not the actual distance. So I didn't let them hit the end, so it didn't go back down to 0. So if let's see if I can now duplicate the original. And now you see how it goes down to 0, it rebounds. Now I didn't let it travel that far. So every time there's different behaviors. Okay. Now, remember, when you have, so we all remember V average equals delta X over delta T is always true. If the acceleration equals to 0, which means straight slope of the xt graph, right? That means that the V final equals V initial also equals what we call V instantaneous, which is just exactly instantaneous, meaning what your speedometer tells you. And if I was in a car and I'm here and I looked at the speedometer, it would always tell me the same thing. It's the average velocity, the final initial, or instantaneous, it's all the same during that interval. So all we have to do is pick any 2 points. We can get an average velocity for any 2 points. So we can calculate the average for any 2 points, and that gives us the velocity instantaneous at that time. So then we can produce a graph of t and v. Now, one thing we're going to also do is, because remember that you have t and you have x, and remember how we could say that, remember the area here is the x, let's see, x times t would be, excuse me, just hold on, Harry, not here, this is v times t gets you the distance, is the area is the distance. And in the case of the triangle, we use 1/2 the base times the height. But now we're going to have a situation where it's constant. Let me just, come on, Harry. I'm sorry, I'm being confusing. Right now, yeah, that's all true. And here's what I wanted to say. So we have this graph here, and we have 2 points in that line up there. So we're going to figure out what's delta x, and we're going to figure out what's delta t. And what we're also going to do is we're going to take the t in between, and so we're going to, and this is going to be, in fact, t average, because when we make a table, we're going to put the t average and the v average in our table. And that just says now that at this time, and it's just because we're using this little interval, it's always good practice to pick the middle of the interval as the time mark. It's tough for, I got to think of better ways to explain it to you guys as 1570 students, but yeah, it's just simply because we're in a, yeah, it's simple, right? We have the 2 points. No, it's not that hard. We have the 2 points of this line, any 2 points, and we're going to get the delta x, the delta t, and that's going to give us a v. And for the time itself, we just want to pick the middle. That's all it is. Yeah, that's easy. T of the middle. And it turns out that t in the middle is just t1 plus t2 over 2. It's the average value. That's all. There we go. Got it. Sorry. And I have notes, and I practiced all this ahead of time. I was actually prepared for class, believe it or not. Okay, I wait a second. We're running out of time. Oh yeah, I forgot 250 grams and 250 grams. Okay. Okay, so this becomes, in this case, 0.250. And this one is 0.250. Okay, so we got to get moving here. So first of all, the velocity here is going to equal, I'm just getting my logbook out of the way and my drawing tablet. So this is going to equal the delta x, and we need open parentheses. So it's in this 2-point interval, it's just that's the final position minus the starting position divided by the final time minus the initial time. And I forgot my parentheses. Just click in here. And of course, it's not going anywhere. And our time is just the halfway point between these two guys. So this equals, open parentheses, the final time plus the initial time divided by 2. And that gets us the halfway point.
Can you show that one more time real quick? Sorry.
Sure. No, that's fine. All right. And then here is the speed of cart 1 in that little interval. And then the speed of cart 2 is equal to cart 2, got to be careful, minus cart 2's initial position. And I divide it by the same time coordinates. And that's cart 2. Did I get this one right? Yeah, got E. And then this should be F. And of course, it's the same time each time. So now, what's the momentum of cart 1? So the momentum equals cart 1's mass, and we need the dollar signs. So you can hit the F4 key. Or you can just click inside here and add the dollar signs times the velocity of cart 1 and the momentum of cart 2 equals the mass of cart 2 and dollar signs times the velocity of cart 2 and then the kinetic energy equals 0. Oops, I got to put equal sign, equals 0.5 times the mass of cart 1. Don't forget the dollar signs times the speed or velocity of cart 1, and we need to square it. And the kinetic energy of cart 2 equals 0.5 times the mass of cart 2, dollar signs, times the speed of cart 2, and we need to square it. So we have the instantaneous, or the average time, the middle of this interval. We have the average speed, which we know because we see a straight line that it's same as the instantaneous speed. So it's delta x over delta t. And same for cart 2. Momentum is that speed times the mass. And again, with the cart 2. And we have 1/2 mv squared for cart 1. And 1/2 mv squared for cart 2. All right, so now we can just do this whole mess all at once. We select all those guys. And we take the fill handle. And we just have to have some patience. You just drag this down. Notice when it happens, when I go a little low like this, it goes faster and moves. And Google Sheet does the same thing. And we are ready. Now, remember, this is after they came to a rest. So there is interest. It gets to be non-zero. There we go. There's some non-zero numbers. Okay, so now this is where, well, this has the same, luckily it's the same time all the time.
Can you show that one more time? How to highlight all that?
Do the fill, yeah. So select all the cells that we type formulas into. Click and drag to select all of them. Then you click on the fill handle, see how the cursor changes from this open cross to a simple cross or positive sign. Click and hold that little guy and just pull down. Once you pull down past the bottom a little bit, it moves. You pull it down further, it goes faster. The thing that's weird is, though, once it gets to the end and it gets into blank cells, it takes off. So you have to be careful. No, they changed that feature. Nice. Good. It used to be that as soon as the fill handle got down here, it would just go and it would go like to 1,000,000 cells really fast. But I guess enough people complained. Oh, we don't go all the way to the bottom. That's right. Because this is not, because see, this one is referencing blank cells, right? So we don't want this last one. There we go. Now let's take a look at things that we can do. Now, I don't know if you can make graphs this way in Google Sheets, but this is another advantage to Excel. Watch the way I select now. I'm selecting entire columns, and there's a reason for that. And let's see, insert, and then we want a scatter plot. Look at that, huh? Now, the reason we do this the way I did it is that I can see here that, okay, at some point, this becomes a flat line and I don't care anymore. So I can go down here, and if you hover, so 4.35 seconds, see, watch. Come on, make a liar out of me. There you go, 4.38 seconds. And in fact, we can see that it's after, even here at 4 seconds. So I can go down here and I look for 4 seconds. There it is. So right away, I know that I don't need this. So instead of going back and doing select data, we can just do this. We can just clear those. And now, see how the graph changed. And then we can also, we see that we don't really care until we reach almost after 2 seconds. So we can actually do something like this. Oops. So we go down to 2 seconds. And then we do delete here. So what we wanted to do was this way. Delete and shift cells up. And now check it out. Pretty nifty, huh? And this is up to you if you want to do this. You don't have to, because what you can also do is, let me show you. You can just merely change. You can do this in, see, you have the minimum, so we make the minimum 2. We make the maximum 4. And now, in fact, this is nice in a way because now we can obviously see the slope. So that's up to you. Okay, now here's what's really cool. Now we can compare momentums and kinetic energies really easily. So we select our instantaneous time. We hold down the control key and we pick momentum, kinetic energy. Well, in fact, let's just keep it simpler. Let's just do the 2 momentums first. And then we insert a scatter chart again. And there you go. And this one, you have to be a little clever, but you can see, and you notice that, for example, this orange graph has this funkiness. I don't know what it is, but that creates these oddball points here. Basically, now you see there's the momentum here, and there is before, let's see, we have before the collision, then the collision happens. Notice they actually switch. Oh, and you can also do things like this. Now here's the fun part. We can do total momentum. And this equals momentum 1 plus momentum 2. And we can see what that produces. So now this thing is ready. Well, we can add other charts, but the basic template is ready. So watch this now. What we do is we can keep this one. So let's call this our, let's rename this one to template. And now we make a copy. And we, depending on, it's different in Google Sheets. So I want to move it to the end, create a copy. And so let's rename this to collision 1, for example. I mean, you should write in your notebook, say collision 1, and then let's look at, we have the manual. And, here we go. So it says here, let's put the blue guy glue cart at 500 grams. Okay, so we do that. Watch this. This is fun. And no, it said blue cart, Harry. Wait a minute. So the blue cart, they want at 500 grams. And where is it? Oh, add 500. So to make a total of 750. Okay. Position the blue cart right between the release and stop. Right. Position the blue cart between the release both and stop cart button. So position right here. Engage the red cart with the launcher. Cock the launch spring back about halfway. Turn on the motion sensor. Release the left cart and.
Professor.
Sorry?
I don't mean to interrupt, but I'm not sure if you know classes ended like.
Yeah, I do. I know. It's being recorded. I just figured you guys are here. We might as well plow ahead so some of us can see it. Yeah. Thank you, though. I mean, if you have to leave, you have to leave. What I want you guys to do for next week is to I'll have a checkpoint notebook, and I want conservate to do. Let's see. This one, you'll answer questions, and right, to do part 1, and part is the kinetic energy part 2. Okay. Yep. So yeah, we're gonna do part 1 and part 2 here. This is pretty straightforward, and at least make up these, fill in the spreadsheet and make some graphs. Okay, so to give you a rough outline, I'll write it up better and post it. Okay, so before the blue card hits the right bumper, turn off. Okay. All right, so it's ready to go. We turn on the that, and release. Stop. Stop this. Okay, so now we've got a graph. Okay, so we need to take, so you would write down in your book, collision 1 is the blue cart with 750 grams, the red cart with 250 grams, the plunger pulled back halfway. So we have 0.25, 0.75, and then we need to clear out only the time and the positions. Don't clear out anything else. Then we delete that. Now it's going to go all crazy on us. Now we go back to the sim, copy, and paste. And now it's all happy again. And now we have, look at that. And then this one, okay, we have to go back to let it auto scale. So now we have a chart, a graph, that looks pretty much the same as that, huh? And we also have the added advantage that we can just read off velocities. Or in this case, this is momentum. You have to be careful. And then you can also ask it to calculate the total momentum for you. So that's pretty cool. But you also have the table where, oh, there, and it asks you questions. And it walks you through this. And so the idea is use this. So this is nice because you can write down, okay, first we did this, then we did that. Now we calculated the initial momentum, and I did it by making my graph here, and I read it off. I see this is my initial momentum, etc., etc. So see if you guys can get through part Roman numeral 1 and Roman numeral 2 here. And with the help of the spreadsheet, it's actually pretty simple. You don't actually have to do much typing. Oh, and one other thing, it shouldn't be a problem, but let's just take a look here. And right, it won't be a problem. I just realized, as long as we remember to clear out everything first. You notice that the new data set's not as big. That's no big deal. Or if, let's say, that the new data set is bigger than our template, then it's just a question of doing this. But most likely you don't even care out at the end anyway. You only care about in the middle. Okay. There we go. So have a crack at that. I will post, I'll get the Zoom video will be available to you soon, but I'll download the Zoom video and slice and dice it so that you can just check back at the parts that you need to get going on this. And I'll make a more detailed description of what I would like you to have done for next week, and I'll post that as well. Yeah, I changed the today notebook until tomorrow. Thank you, Tamara, if you're still here. Yeah, because you guys weren't able, some of us weren't able to get the sim to work. So I'd like you in your quote lab day notebook to describe the apparatus. There you go. Okay, so I will type up a more detailed description of what I'd like you to have done for the next week. And again, it's basically to take your template, follow the instructions in part one and part two, and use your template um, to calculate kinetic energies, momentums, and the total before and after. So it should be pretty, it should just be what we call donkey work once you've got the spreadsheet going on. All right, any questions, guys? And again, don't stress out if it's not, there's no right or wrong answer. I'm just interested to see that you worked hard on it, you tried, and next week we'll do it together and make sure everybody has the right answers. Okay. So will the Zoom, yeah. If you, the Zoom recording, you can see it, you'll have to like scroll through it. And when it takes me time, yep, if you have to go, you have to go. I can download the recording myself, and then I have a software where I can cut it up into pieces. Where, for example, if you look at the YouTube playlist for linear acceleration, it's a combination of the pieces from the Zoom video plus recordings that I made on my own. So I'll make announcements as I get things ready, published. But you can always, of course, again, look at the Zoom recording yourself. It's just it'll be a long thing, and you'll have to sort of move the slider around looking for the part you need. All right. Yeah, same. That's nothing new there. Okay, guys, I am shot. I'm gonna say goodbye for now. Not go.
Professor,
Oh, sorry, Jenny.
I'm sorry. No, it's okay. I just wanted to ask you a question on the actual physics book that I have for physics.
Yeah. Oh,
um,
yeah. The textbook itself. Okay.
yeah, I asked my instructor, but I don't really understand it. So I was wondering if what equation you would use for this question. It says you slam on your automobile brakes sliding 40 feet with locked brakes. How much
Uh-huh.
farther? How much farther would you slide if you had been moving twice as fast? I'm confused
Yeah.
on what
Yeah.
equation to use.
Yep. I got it. Yeah. That's not a trivial question.